Hello dear learners, welcome to this tutorial. In this tutorial we are looking at statistical charts and graphs. I am your mathematics teacher Ademola Folarin. This tutorial is powered by Hyota Virtual Learning. So when we say statistical graphs and charts, these are basically graphs that we use in representing data in statistics. So they range from the bar chart, the pie chart, histogram, frequency polygon, cumulative frequency curve, and so on. So those are statistical graphs that we use. Taking a look at this, the bar chart, which is the one that we have here, bar chart is the one we have here. This is bar chart. This is histogram. This is pie chart. And this is frequency polygon. This is cumulative frequency curve. All these are very, very important charts in statistics. The bar charts, which have the rectangular blocks separated here, the bar chart and the pie chart, they are used basically for discrete data, that is ungrouped data. They are used for discrete data, while the histogram, the ones with rectangular blocks close to each other, the histogram, the cumulative frequency curve, the frequency polygon, these are used for grouped data. They are used for grouped data. So all this and more are charts and graphs that are used in statistics. So we learn how they are prepared based on given data in the subsequent examples that we are going to be exposed to here. So let's move further. We have this example. The question here is asking us to prepare a bar chart for this distribution and a pie chart. Interestingly, this type of distribution is the one we call the discrete data, ungrouped data, where we are having the quality and the frequency of it. You're having an event and the frequency of it. So that's how we work this. And to do this now for our chart, we definitely we want to draw bar chart. To draw bar chart, we first have to design the table for bar chart, the graph for it. Let's have a graph for bar chart. Yeah. So we rule this. We are plotting the frequency. We are plotting the frequency against the event, against fruit. That's what we are doing. Frequency against fruit. So in this situation, we may decide to say this one starting from here 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the frequency region, and this is the event, that's the fruit we are plotting. So we may represent each of these. Let's call this place mango, and we leave this column for orange. We leave this for purple. We leave this for berry, and we use this for watermelon. So to do this now, what we then need to do for each of these is to place the frequency of it. Mango has 4, that's the frequency of it, 4, so we put it the rectangular form of equal size. So this is for mango. The next is orange that has 7. We go to where we have 7 as the frequency. We draw it. Remember, bar charts, they are always separated. Unlike histogram that has its bars close together, in bar chart they are separated. So the next purple, which is 9. Put the graph on 9. The next is berry, which is 6. That's the frequency of berry, 6. And the last is the frequency of 4, which is watermelon. Frequency of 4. So interestingly, we've prepared a bar chart. Now, taking a look at this, the advantage of bar chart is a simple form of statistical graph that it can easily be read even by someone who is not a specialist in statistics. Taking a look at this, this is the highest bar. So upon seeing this, anyone can know that this is the one with the highest frequency. That is, this is the event that occurs most. In health, in education, name it, in industry, they use this graph. Take for example in health sector where you are talking about a particular disease and the number of people that has been killed by that disease or that has been affected by that disease. Anybody coming to the clinic to say, oh, look at this disease with the highest bar, so it's the one that kills the most. It's easy to interpret. That is a very good one for bar chart. This is bar chart for the distribution given to us here. The next is for us to prepare pie chart. In preparing pie chart, there are things that goes into preparing pie chart. To do pie chart, you need to work on this data more. We extend this so that we can prepare for the angle, because pie chart requires that you share the given data into angles. So we do it this way. Or better still, let's just follow the simple way of this. Now we want to construct angle for it. How do we do the angle? To do the angle, remember this total sum of this, we have to add the total sum of the frequency. 4 plus 7 plus 9 plus 6 plus 4, and that gives us 30. 30 is the total frequency. So to get angle for each is going to be each of the value. Let's say for mango, we want to determine the angle for mango is going to be 4, the number of the frequency of mango divided by total frequency, which is 30, multiplied by 360. So that is how we do it. That's 4 over 30 times 360 degrees. That will tell us what the angle will be. So that's 48. 48, that's the angle. We do the same thing here. 7 over 30 multiplied by 360 degrees. That's 84 degrees. Here we also do 9 over 30 multiplied by 360 degrees. That's 9 divided by 30 all multiplied by 360 degrees. That gives us 108 degrees. We do the same thing here. 6 over 30 multiplied by 360 degrees. 6 divided by 30 multiplied by 360 degrees. That gives us 72 degrees. And lastly, 4 over 30 multiplied by 360 degrees. That gives us 48. We've done that here. 48 degrees. So add all this together. You must confirm that it gives us 360. 360 degrees. Now that that is sure that it gives us 360 degrees, the next thing is for us to construct our pie chart. By constructing our pie chart, it means we are drawing a very big circle, 360 degrees. So we take note of the center of that circle, this being the center of this circle. Now we share this circle into sectors based on all this. So we can use our compass in doing that. But in the absence of your compass, nobody is expecting it to be totally perfect, especially in your exams such as WAEC, NECO, IGCSE. But they want to see something so close. So if there is no compass with you, if there is no protractor that you are going to use to measure the angle, you can do something so close, and that is what we are going to do here. At least you know that you can divide this. The first thing, if I do this and I take this up, that gives me 90, right? If I take this up like this, that gives me 90. So I'm not taking it up. I want to get 84, which is close to 90. So this is 84 degrees. The next, that 84 degrees, what can I still make out of it? So from here, also, take note that if I draw this downward, that gives me a sector of 90, but I have 108 instead of 90 here, 110, 108. If I do it this way, so it shows that this, what I've drawn, if I'm to trace this one straight, this shows that it's bigger than 180. So what we just need to draw something so close to it, 108 degrees. Now in 108 degrees, I've been able to make these two. So I need 48. I can just pick 72 out of this 108. If I do this 72, so to complete this sector now is something like this. So I can call this my 72 degrees. And dividing this into two equal parts, I have 48 and 48. So isn't that interesting? You have this 48 degrees here, and you have another 48 degrees. So which means I can give each of it name. The first 48, let's call it the mango. 84, that's orange. 108 degree, that's purple. 72 degree, that's berry. And the last part is the watermelon. So we've been able to prepare a pie chart for this problem. And from there you can easily see that the one with the highest frequency, 108, is the largest sector, followed by the orange, which is 84, and followed by berry, hence mango and watermelon. So we've been able to prepare pie charts for this. We've learned pie chart and we've also learned bar chart now. Moving forward, let's take another example. Taking a look at this, we are asked to prepare a frequency curve, cumulative frequency curve. In this problem, cumulative frequency curve. If we are to prepare cumulative frequency curve, then that means you need cumulative frequency. You also need class boundaries, cumulative frequency and class boundary. So since we know that we are going to be in need of those things, let's extend this colon to prepare for it. So let's say we have it this way. The part of let's make this one the part of cumulative frequency, CF, cumulative frequency, and this is the part of class boundaries. Most importantly, what we need is the upper boundaries, but we are going to design everything so easily here. So for cumulative frequency, how do we get that? This starts by saying 8 plus 6, that gives us 14. 14 plus 12, that gives us 26. 26 plus 9, that gives us 35. 35 plus 7, that gives us 42. 42 plus 8, that gives us 50. Recall the total frequency of it, if we add it up, when you add this plus this plus this plus this plus this, must give you 50, just as it's stated here. So the cumulative frequency helps you to confirm whatever lasts this point of cumulative frequency must be equal to the total frequency of the distribution. Now that we have this, we need class boundaries. By class boundaries, the class boundary is that you remove 0.5 from the lower limit to get the lower limit of the class boundary. You remove 0.5 from the lower limit of the class interval to get the lower limit of class boundary. So subtracting 0.5 from here, you have 44.5. Add that 0.5 to this, you have 49.5. So the end of one class boundary starts the other class boundary. So here 49.5, do the same thing here, subtract 0.5, you still give you 49.5, which ends here, and it starts this, minus 54.5. So do the same, 54.5 minus 59.5. For this is going to be 59.5 minus 64.5, and this will give us 64.5 minus 69.5, and lastly 69.5 minus 74.5. Now the class boundary is designed. So to plot cumulative frequency curve for this distribution, we'll do that on our graph. Take out your graph. We are here plotting cumulative frequency against the class boundary. That is what we are going to be doing with the graph. We'll plot the cumulative frequency against the class boundary. So to do that, we have our sketch of it. Cumulative frequency curve. We want to plot that against the class boundary. So this goes this way. Sorry. Okay, let me line this correctly. This. Then we plot this. So we label them out. This part is the cumulative frequency. Cumulative frequency CF, that's the region of cumulative frequency, and this is class boundaries. So we start from the upper boundaries here. We can pick that to be here 49.5 followed by 54.5 followed by 59.5 followed by 64.5 followed by 69.5 followed by 74.5. Now this point is seen as a 0. let's learn something. What we are saying now is 0 to 49.5. The size captured by 0 to 49.5 is not of the same size with this. So in order not to be penalized for that, there is one thing. We start from 0. So whenever you don't start from 0, to make sure that each of the boxes are of equal magnitude. This did not start from 0. So I cannot say 0 to 49.5 is this, and this is 49 to 54.5. No, it's not of the same size. So to do this, let me show that I have extrapolated some values. So that's the meaning of this. Doing this now shows that I've extrapolated some value to make this equal size with this, with this, with this. So that is one thing we must take note when we are not starting from the origin for the class boundaries. So for cumulative frequency here, you know the maximum of our frequency is 50. So how best can we divide this if we say 10, 20, 30, 40, 50? Okay. So let's take this as 10, 20, 30, 40, and this is 50. So this is our cumulative frequency. This is our class boundary. Now the next thing for us is to plot. When the cumulative frequency is 8, the upper class boundary is 49.5. So at 8 is here, is 49.5. When it is 14, the upper class boundary is 54.5. So 54.5, I look at 40, this is 12. So 14 is here. When it is 59.5, the cumulative frequency is 26. You go to where we have 26, this is 22, 24, 26. So this is 26. When it is 64.5, it's 35. 64.5, I see that's at 35 here. 32, 34, 35 is in the middle here. So when it is 69, it gives us 42. So 42 is here. And when it is 74.5, we have the cumulative frequency to be 50. So this is the cumulative frequency. So interestingly, now that we have gotten this, we can then plot. This. It's easier for us to plot this now on the graph by saying we have this plot from this. I know you plotting, you are watching, you can easily plot on your graph. Not minding my own curve. So this is our cumulative frequency curve. We have plotted class boundary against the cumulative frequency curve. So now that we know this, what is then expected of us? Here we have done the curve, but the question is saying from our curve, this curve, if you want to start from 0, you can just show this. From this, we should work on our interquartile range. We should determine interquartile range. So how best can we determine the interquartile range? To determine the interquartile range, remember that interquartile range equals Q3 minus Q1. The Q3 itself, the way we solve it separately. Let's do Q3 separately. Q3 means third quartile. So to do that is 3 multiplied by the total frequency, which is 50, 3 multiplied by the total frequency 50 divided by 4 position. So if we do this, our Q3 will be equals to, doing this, that will be 3 times 50, 150 divided by 4, you get 37.5 position. That's Q3. For your Q1, we are going to do, that's just n over 40th position. N over 40th position, and our n is 50. So that will be 50 divided by 4. Remember, n over 4th position. That is our Q1. N over 4th position. So divide this one, you're going to get 12.5th position. So you will now come to your curve here to find out those things. The first one, Q3, we go to 35.5th position on the frequency. 37.5 position on the frequency. So you go to where you see this is 32, 34, 36, 37 position on the frequency is here. So we trace that out, 37 position till it touches our curve. So it touches the curve somewhere here. Trace down where it touches the curve to the class boundary. So that is a box after 64.5. And from 64.5 to 69.5 is just 5 difference. So that means each box here represents 1 unit. So that will be our Q. It means our Q3 here on that position is 65.5. Or 65, sorry, since they both have 0.5. So it's just 5 position. That's 65. So 65 minus, let's look out for the Q1, which is 12.5 position. This is 12.5 position. So it's going to be somewhere here. If we trace it on that curve, so that gives us something of this. This one, this is where we have our Q3. This is where we have our Q1. So this is just one box before 54.5. That's 53. So we have that one as 53. So our Q1 is equals to 53. So finding the difference between this and this, we are left with saying 65 minus 53. Subtract 53 from 65. That gives you 12. Hence, interquartile range Q3 minus Q1 is equals to 12. So interquartile range in this question, interquartile range is 12. You can put it there. So that is how we prepare frequency cumulative curve. One of the important graphs used in presenting grouped data. If you enjoyed this, don't forget to click on the like button and as well subscribe to this channel for more educative videos like this. Till I come your way next time, I am your tutor, Ademola Folarin. See you next class.